Good afternoon. I'm Paul Watson. Obviously, this is Peter Moody with me. We're here to talk about network ACL and filtering management at Google, where we work. The talk today is called Unum Pluribus, which is kind of a flip-flop from Pluribus Unum, which many of you know, and it means out of one, many. So I wanted to start off giving a kind of a brief overview of Google. So many of you, how many people here are network engineers, like full-time network guys? How many of you absolutely hated me because you had to work really long weekends about 4 years ago when the BGP reset thing came out? Does anybody absolutely hate me and is going to shoot me or something?
I'll take a bullet.
Okay, hold on. I got to apologize to this guy. That's for you. I'm sorry. It got a little overblown. Anyway, so at Google today, we have about 6,000 VIPs, or virtual IPs. Each virtual IP is basically a public IP that may map to 1 or 100 different back-end systems that it load balances. And many of these individual VIPs may represent one or more services. We may have HTTP configured on a VIP, as well as Google Talk and IMAP, for example. Excuse me. We have around 100 distinctive service ports, such as HTTP, SMTP, IMAP, on and on and on. Google's not just the web anymore. We've got a ton of services that we're using. HTTP and HTTPS alone comprise probably 4,600 VIPs around the globe, with countless back-end systems on the tail end of that. We've also had a huge deployment of edge caching. Obviously, when you're peering with large ISPs, you don't want to take large streams of data and carry it all the way across the internet to the client, so you want to try to get content as localized as you can. Many of you are familiar with like Akamai's deployments. We're trying to get along that, doing stuff along that way as well, which leads to interesting security requirements. Recently, Facebook talked about having like over 30,000 servers. I can tell you right now that the work me and Peter do protecting Google's infrastructure, that would amount to about a rounding error on the number of systems we're trying to keep track of. But unfortunately, our PR team won't let us release any specific numbers, as you've probably run into before. At Google, we have some very specific needs on how we filter. We've got our production network. Typically, Google breaks its company into two parts. We've got our corporate network and our production network. And a production network is where most people get their services from Google, the web search, the Gmail, and so forth. We also have our edge caching services that are deployed all around the globe. We have our corporate filtering we have to deal with. We've got internal filtering, such we may have a team working on a very special project that we want to filter off from the rest of the corporate network because we don't want other employees to get access to it, or maybe they're doing something sensitive that they don't want to escape out of the lab. I'll let you infer why that could be. We also have sometimes contractors that we don't want to give full access to the network, so we've got to kind of restrict the access they can have internally. Many other special needs projects. And we also have been doing a lot of acquisitions over our history at Google. And naturally, when you first acquire a really large company, you don't want to just say, I absolutely trust them, let's just plug them into our network and assume that they're completely secure. Because a lot of people really depend on Google for their privacy and security, so we treat our acquisitions as pretty much hostile when we first acquire them until we are absolutely assured that their network is safe and secure and meets our standards before we fully integrate them. So therefore, we have some unique requirements because maybe we acquire a really large video provider and they want to take advantage of our bandwidth capabilities, which that we can do cheaper than a lot of peering that they can get. So we may want to let them use the Google backbone for a transit network, but not actually let them have free reign of our network. So we have filtering requirements there as well. And then we also have individual hosts and network or services we want to filter. For example, maybe we have a Kerberos host that's running in our network, and we want to protect that from the general corporate users, but we don't want to have to put up a specialized firewall just to protect an LDAP server, a Kerberos server. We have used stateful firewalls, and we continue to use stateful firewalls in some places, but as many of you know, they're limited in scope. Sometimes bandwidth can be an issue. Sometimes you don't need the full capabilities of stateful firewalls, and it can also be quite expensive at times. So one of the problems when I joined Google a little over 5 years ago was every ACL we managed was pretty much manually written. If we had an edge filter that controlled what access could come into our production network, it was a really long ACL, sometimes thousands of lines long, and whenever there was a change required, maybe we added a new network block, we had to go through and manually walk through that ACL, look for every place that may be affected and update it. And that's just one ACL. We had hundreds. So someone would have to walk through every ACL and keep everything in sync and manually update all these files. It was horrible and it was painful. But that's back when Google was smaller and didn't change as much. So anyway, we also ran into the problem where we had multiple formats. Sometimes we had Cisco ACL, sometimes we had a Juniper ACL, sometimes we had a NetScreen firewall that we're trying to keep all these addresses and networks in sync between. Very difficult to do, very time-consuming, and very prone to typos. I'm sure everyone here at some point who's written an ACL has mistyped a net mask or a host mask. It happens all the time. Or transposed digits in a network address. So we had several projects over the course of time. One thing that's nice about Google is everyone in there is extremely smart and extremely capable. So whenever someone sees a problem, rather than just complaining about the problem, they actually tend to automate things and find ways to make things better. But one of the problems with that was people were fixing very specific problems and not taking it as a general overall problem on how to resolve that. So that's one of the things me and Peter jumped in.
Okay, so what we did, as Tony had mentioned, there were a number of projects that we had internally that were already trying to fix this problem of standardizing the definitions, the address definitions, so that when we referred to a production network, that production network meant the same thing in this ACL and this ACL and this ACL. So we decided to unify them. So what we did was we came up with a meta language to describe these, to describe the addresses and the various services, so that SMTP means 25 TCP and DNS means 53 TCP or 53 UDP. This slide just talks about some of the core principles that we were trying to follow in this meta language. So the language should define a policy. It should be clear and easy to read. It should be in English. It's I've thankfully never had to deal with M4 configuration files, but that's always been in the back of my mind as something that I want to do everything I possibly can to avoid. Policy should be able to share common object and definitions, so hosts and addresses and network services should be common across them all. And it should lead to, as much as possible, it should lead to the automation of the process, so that, ideally we could get to a point where we could run, change an address definition, run make, and every place that this address definition is used, we have brand new firewall filters grabbing in that new address definition. And then finally, write once, output many, sort of kind of like the Java, but actually write once, output many.
Yeah. So you can write your ACL once, output it to many different formats, hence the name Unum Pluribus.
So the initial design, we wanted to make this modular. There are a few pieces on the right-hand side here that go into our complete ACL generation process. So we're going to go into further detail on these in the later slides, but just a brief rundown. The naming library, the naming library actually goes off and reads in the definition. So reads that the production network is, say, 10/8, reads that YouTube has these addresses, reads that SMTP is 25 TCP. There's an IP address library. We want to do lots of things with our IP addresses. Like if you have addresses that, several contiguous net blocks, it'd be nice to be able to summarize several contiguous /24s into maybe a /22. The policy library, which actually goes through and reads the individual policy files, which we'll talk about later. And then eventually the generators. So this policy library goes off and reads the policy, grabs the stuff from the naming library, does all of its magic, and then hands this giant policy object off to whatever one of these access list generators that we have, Juniper. So right now we support Juniper, IP tables, various Ciscos. And ACLGen is the actual process that unifies everything, that goes off and calls all the different pieces that actually do all the heavy lifting itself. And then, of course, unit tests, just to make sure that what we're doing is correct. So this is a very non-complex diagram that shows more or less how everything works. I get confused when I look at this, but Tony had a really good...
Sure. In basic, what we're showing here in this diagram is that we've got these definition files that describe networks and services. And we've got policy files that describe our security policy. Both of them are manual text files that a human can easily edit and read. I know a lot of people are really on this big kick of XML this and protobuf that. We wanted something that just an average guy could go in and read and edit easily. So you start with a naming library. The naming library reads a directory, and every time it finds a file with .NET, it says that's a network definition file. Whenever it sees a file with .svc, that's a services definition file. Reads all these in and builds a big object. Now all the network objects are composed of what we call a NAC adder, which is a subclass of the IP address library that Peter wrote, and he'll talk about that in a little bit. So now that we've got this huge big naming definitions object, we pass that down to the policy generator. The policy generator reads in the security policy descriptions, applies the naming definitions to it, so wherever it sees a token like RFC 1918, it goes, oh, I know what that means because the naming library tells me that's internal addresses of this, this, and this. And then it takes that policy object that it creates, which is kind of a standard interoperable way of saying what a policy looks like in a very programmatic way, and we pass it down to a generator, which at the end of the day is a parser. Now it takes that policy object that is the security policy with all the addresses and ports and protocols, and each generator says, how do I describe this in a way that a Cisco will understand, or a Juniper router will understand, or IP tables will understand? So it's very programmatic, and the nice part about it is if you don't use Cisco, Juniper, or IP tables, you can grab a policy object, write your own generator to output a format for a NetScreen firewall or a checkpoint firewall, and it can still create an output. So you can expand the generators out any way you want.
I wish you good luck if you want to write an output generator, though, for NetScreen or Checkpoint.
It could be a little trickier. So the next few slides, we're going to walk through kind of an overview of some of the different libraries, because we've kind of said there's this naming library and a policy library. We're going to tell you exactly what those mean and how you can use them. And because they're very modular, it may be that you see something you like about the naming library and you could care less about the rest, and you could download it when we release the code and just use that in your own particular software project if you decide it's useful to you, and throw the rest away. The system we've designed pretty much is command line based, what we're releasing today. We'll talk a little bit later, but what we're releasing today is not a lot different, but in many ways different than what we use in-house in Google. Google has a lot of really cool tools and resources available to us that we can use that we can't necessarily release to the public. So we've done a pretty good effort over the past few months ripping all this code out of the Google code base, getting rid of all the Google dependencies so that you can just download it, run it on a laptop, a Windows, a Mac, Linux, whatever, without having to have all the other Google dependencies. As a side to that, sometimes you don't get all the cool stuff, but we'll still tell you about some of the other stuff we've done in-house so that if you want to replicate it, if you decide to use this yourself, it would be easy to do. And we also believe in the idea of kind of release early, release often. It may not be 100% perfect right now, but the nice part about releasing early is if other people are interested and they want to join in the development efforts, they can jump in, help us out from the get-go. So the first library that's kind of, if we build a couple of blocks, the first place you would start is the naming library. How many of you guys manage firewalls? Almost every firewall management has a way you would define a network or a service. It's very common boilerplate stuff. So our naming library provides an easy way to look up addresses, services, naming tokens, and so forth. And we use files as the source data for that. One of the nice things about the naming library is you can have one file, like when you download our current release, there's one file called network.net that defines some really basic network tokens like bogons and RFC 1918 and so forth. But if, for example, you had 2 or 3 teams that were all frequently owned certain types of addresses, like maybe you have a Corp SysOps teams that say, we will define what machines are LDAP servers. And you have a network team that says, we will keep track of what is a bogon and what is a public IP. You can actually create 2 or 3 files set your file permissions on it so that only members of your NetOps team could update the bogons list. And whenever somebody runs this naming library and generates an object, it will pull in their data. So you can have authoritative sources control who does what. Same thing with service definitions. It can be one file, it can be 100 files. You could break them up by usage or different groups, and blah, 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 blah. Obviously, you want to have a naming standard, which you guys all work in large administrations, you probably know that. So let's look at like what a text file format would look like. You can just say something like RFC 1918 equals, and define a couple of networks and a couple of comments next to it. You can nest tokens. So you can say internal equals RFC 1918. You can say loopback equals 127.0.0.1/32, and also define it as an IPv6 address. And some of the generators know how to handle IPv6, so it can actually render IPv6 output format along with it. You can also create groups, such as here we defined a New York, San Francisco, and a Chicago office, and then we just create another token that says offices, and we include all those offices in it. And you notice you can have multiple tokens spanning lines. It doesn't matter. Services, very similar. Define a token name, equals, and some values. Like here we'll see 43 UDP. You can also say, for like DNS here at the bottom, 53 TCP and 53 UDP. And you can also nest them as well, like mail services, SMTP, ESMTP, POP, SSL.
And important to note here, ranges are also supported as well. So you can have like high ports equals 1024-65535/TCP. So the generators would then know that you're dealing with a range there. You're not dealing with an individual port.
That's a really good point. I should probably put that in there.
That's okay.
So let's see how you would use this naming library. So how many people use Python? Anybody?
Congratulations.
Who used to use Perl and switched to Python?
Congratulations.
I see 2. Either of you married?
Congratulations.
Committed relationship? No? Yeah? Okay. Here, this is for your committed other. Okay. So what you do when you're using Python, you'd basically just import your naming library, which we provide. Then you create an object and you say definitions equals naming.naming, and you give a path to a directory. Now it slurps in all those files, and you can start using them. So Python has a really neat way to find out the different methods available to an object. You can type dir, and in parentheses, your object. So in this case, dir definitions tells us a lot of the methods that are available here. So you'll see we have these methods like get IP parents, get net adder, get service, on and on and on. The common ways you would use it is you might say definitions.getNet and some token name, internal, for example. And internal will return a list of 3 different objects. An IPv4 object, 10.0.0.0/8, an IPv4, and basically our RFC 1918 objects. Now you'll note that this doesn't just return a text blob of the IP. It actually returns an IP adder object. We'll show you why in the next slide, exactly why that's important, why we didn't just want to include text. We wanted to be able to do something a lot more cool with that. Did you have something?
Yeah, no, strictly speaking, it's NAC adder objects. But
technically, it's a NAC adder, which is a subclass of IP adder. The reason we have, Peter actually wrote the IP adder object library that we're using, but we created a subclass of that to use for this particular project, because one of the things that's important is we wanted to be able to carry the token name and the parent token name, in the case of nested tokens, along with an address. So at some point when I've got a policy object and I want to go back and say, you know, I see 10.0.0.8, but is that part of RFC 1918, or is that part of bogons, or is that part of internal? What token does that belong to? And did that come from a parent, or from a nested token? So you'll see as we go along. So now you've got, say you want to get a service, DNS. You would call your definitions object and the method getService and the name DNS. And it would return a list, 53 TCP and 53 UDP. Now maybe you only want the TCP service only. You could say getService by proto, DNS, and TCP, and it will just return a list of all the ports of that protocol for that token, in this case 53. So I'm going to let Peter talk a little more about his child, the IP adder and the NAC adder object.
I'm in a committed relationship with Python, and we had a baby. So, as Tony said, NACadder is what we use for this specifically. This is based on the IPadder module. I don't know if any of you are on Python dev, but I'm trying to get IPadder included in Python. There's been a lot of discussion about that recently.
It's being included.
Most likely. Anyway, so some of this stuff is a little bit different. This is all based on the 1.x version of IPadder. There's a 2.x. Some of this stuff is going to change in the near future. Anyway, so just a general overview of the IPadder library. It's a fast, lightweight IP address manipulation. As I said, we use NACadder internally, which is a subclass of IPadder. And so this right here, IP equals NACadder.ip, this is just an example of creating a NACadder object. And you give it the address definition, you give it the comment. So the comment was what you saw before, which was whatever was after the hash marks. So if you wanted to keep like non-public, in the RFC 1918 block, what gets passed to NACadder.ip is 10.0.0/8. The token name RFC 1918, as well as the hash, non-public. It turns out to be really useful, obviously, when you're generating your firewall rules to see the comments. You might say, this was because the CEO demanded to be able to access this from his house. So the text comment token, those are optional. You don't actually need them there, but as I said, oftentimes it's very helpful to have them. Yeah, text comment, optional, provide extension to the base library, yeah, whatever. So let's look a little bit more closely at this. As I said, a lot of these are going to change with the 2.0 version, but this is what's available right now. These are the types of things that, methods that provide information about the various addresses. So like the version, the text token, I don't know exactly how interesting a lot of these things are for this. But yeah, this is just a very brief overview of the IPadder/NACadder library.
But the really neat part about it is all you have to do is import the NACadder library and say IP equals NACadder.ip and some IP address, 10.113/26. That's it. And then all of a sudden you can just say, what is the IP version of this address? And it can be an IPv6 or an IPv4. You can ask, what's the host mask? What's the net mask? If you create 2 or 3, you can say, is this one greater than that one? Is this host mask more specific than that one? Is this IP inclusive of this one? Is it a subnet or a supernet of this one?
You can do things like, you can combine contiguous addresses into one greater address. You can.
One of the problems here is Peter wrote it, so he's a very humble guy. This IPadder library is wicked cool. And it makes things so easy to do in Python with IP address manipulation that if you use nothing else here, you will want to play with this if you do anything with IPs and use Python. You need to be more assertive, man.
Tony's
This thing is
buttering me
awesome.
up because he wants me to keep talking. So the policy library is the other. I mean, I can keep talking about IPadder if you want. So the policy library is, when I like to think of this in computer sciencey terms, this is more or less the actual compiler. So the policy library, what the policy library does is the policy library actually goes out and slurps in the policy definition file, the .pol file. It's just named .pol by convention. And parses it all. We go into a little bit more detail about the policy format in a little bit, but it reads in the file, parses the, figures out what type of access control this is going to generate, whether it's going to be a Juniper, Cisco, IP tables, reads the individual terms, grabs the token names of like source address internal, turns those into an address, turns those into 10/8, 192.168/12/16, and 172.1.6/12, turns names like DNS into protocol TCP port 53. Does all this stuff and creates a policy object which will be presented to one or more of the renderers. Each policy definition contains one or more filters. The filter is it's a header section that has an optional comment about what this particular filter is for, as well as a target, which defines the platform, and then some various platform-specific options, like whether it's an INET or INET 6, for Juniper if it's a bridge filter, for Cisco if it's going to be an extended access control list or not. As we've said, we wrote this for what we do at work, and currently we don't actually use any of these firewalls for NATing devices.
NAT's handled by other stuff, so we didn't actually include any support for NAT. I'm sure if any of you guys are actually looking to use this for, you know, a small office setup, a home setup, or whatever, NAT is probably something that's going to be really important. We were pressed for time to get everything, you know, get all the Google dependencies out of here, so we didn't actually have a time to add NAT support. We would love patches. So yeah, so there's no NAT, sorry. Policy language has, yeah, so there's both required and optionally supported statements. The required things are the address definitions and for the generators have to support certain keywords. Not all of the keywords are supported in all of the generators. Unfortunately, you have some generators that are very, very full-featured and some that aren't nearly as full-featured.
Right. So when you're talking about like a security policy, source address, destination address should always matter. But some things like QoS, when you're talking about some ACL formats, may not matter because maybe you're outputting to a platform that doesn't understand QoS because it was, you know, some old filtering software from the 1990s.
It's ancient.
Ancient, crusty, horrible stuff.
Yeah.
Or maybe you're talking about a destination prefix, which matters on a Juniper, but doesn't make a lot of sense in IP tables. So that's why we support both optional and required policy language for the different generators.
The goal was, just to be clear, the goal was to have all of the options actually mean something in each of the rendered, each of the generators. But it turns out that that's a laudable goal, but it's incredibly difficult to actually implement.
Right. So the only requirement we have in a generator is that when you receive a policy object and someone says QoS, that the generator does something intelligent with it. If we're saying,
ignore.
If I don't support destination address, right, and someone says this should only be able to go to this destination address and you can't support destination address in this generator, you shouldn't just ignore it. You should err out and say, whoa, you're using something I can't support. But if you're doing something like QoS, maybe it's okay to output an IP tables filter because we don't have support for QoS, because we still get the same security policy, even though we may not support your quality of service requirements.
So here's just a brief example of a policy definition file. You can see you have the header, there's a comment. This is going to be outputted up at the top in whatever format is actually understood by the various, by the particular platform. So like for IP tables, that's going to output at the top and, you know, behind a hash mark. For Juniper, that's going to have this C /* comment notation. And for Cisco, that's going to output after a remark. Or I guess there's a comment and a remark stanza in Cisco. Anyway, that's going to output in a section that you should basically be able to take this and paste this directly into your device. With the IP tables, you paste it directly into like SBIN IP tables on each of the lines. But yeah, anyway. So this defines two terms. There's a term discard spoofs that defines a source address of RC 1918, denies all that traffic that permit IPsec access. Remote offices are allowed to get to VPN hubs on protocol 50. And then this is a brief example of this is actually what it renders. So that policy renders, except I think I was missing the IP tables definition, the IP tables target.
Yeah.
But this is what that actually renders. So you can see that same policy turned this into an extended access control list. So there's a remark discard spoofs. So that top one right there came from the discard spoofs term, and the second one came from the permit IPsec access term. And then the example.ipt, I guess that creates jump tables, is that?
Yeah.
Okay. Creates new tables and then adds them to the table and then adds that table to the input filter. And then finally, this very tiny printed one is what it actually renders for Juniper. Remarkably for Juniper, this is actually a lot longer than the other ones. Normally, I don't know if you guys are used to dealing with Cisco, Juniper, whatever. Normally, Juniper has a much more concise way of describing. It turns out that Junipers, you can usually describe them in much fewer lines, but this is obviously not the example.
One other thing to note, like when Peter was talking earlier about the IP address library doesn't support things like carrying a token name or a comment. and the NACadder subclass that we're using here does, one of the nice parts is since you're passing that NACadder object to the policy, which then passes it to the generator, if your generator supports verbose comments, you can do things like you see here where it says 110/24, and we'll just include a comment that says, this is remote office, which comes all the way back from the naming file. It says, this is the remote office. Or maybe you want your generator to say, this was part of internal networks. And you could just put out the token name that that's included in. So when you're later debugging the output JCL, you can go back and say, wait, where did these come from? Should I look at the token, or maybe I want to keep the description, or maybe I want to put both. You can do it any way you want. The current generators we have, we've decided just to keep the comment and carry that through.
Did you want to?
So currently today, as we've discussed earlier, we got 3 generator libraries that we're using because these are what we use in Google, which is Juniper, Cisco, and IP tables. The Juniper can support 3 different output formats, IPv4, IPv6, and bridge filters. Bridge filters were something we added recently because we actually had a need for it.
Bridge filters, for anybody that cares, they're essentially a way to apply layer 3 filters at a layer 2 interface. That's all. They're very, very similar to regular INET, INET 6 filters, but they have some slightly different syntax.
And in the Cisco format we support 3 different output formats, which everybody's familiar with, standard and extended ACLs. Well, then there's a new thing called object groups, which is kind of like what we're doing here, which is it creates a small naming definition and a service definition and then saves those. And then when you write your ACL, you can embed the token names in that for those address lookups. And we support that output format as well. And with IP tables, we have 2 output formats, IPv4 and IPv6, that you can specify. So on the Cisco renderer, renders output in Cisco format. Surprise. By default, if you only say my target is Cisco, foobar, it's going to output an extended access list named foobar for Cisco. We support extended, standard, and object group, as we said. We have no support for IPv6 at this time in the Cisco generator. If you need it, add it, submit the patches back, and everybody gets to benefit. It's a wonderful thing.
And then add some slides in here and come on the speaker circuit with us.
It's not a bad idea, Anyway, and they can do the talking, and we can go sit and
That's
live.
right.
Okay, check our email. How many people are reading email right now? Quick. So, we got one honest guy. Okay, honest guy gets a Google Do No Evil t-shirt.
Okay. Oh, Tony.
Wait, hold on. I'm sorry. We also have ladies' large shirts. I'll give it to a friend. Oh, or him. I'll admit, whenever I listen to talks, most of the time I spend my time reading email as well.
When giving talks, I spend most of the time reading email as well.
You were, weren't you?
Yeah.
So when we generate the Cisco output format, one of the things we wanted to do is make it real easy to apply that filter. So the output will actually begin with no IP access list, whatever we called that filter. Quickly followed by IP access list, and we redefine it. So basically it's going to delete that filter and then immediately recreate it with our new output. Makes it real easy to cut and paste. Or if you've got automated tools that just pushes those commands to the router, it takes effect. Now, Cisco access lists tend to be, unlike Juniper, a long list of individual lines. And one of the things we found out when we first started writing the generator for Cisco was sometimes we would end up with 800 lines, individual ACL lines, and then going back through that at some point trying to look and verify our output. It didn't make a lot of sense. It was kind of hard to debug. So we decided to include remarks. So you'll have the IP access list foobar defined. Then you'll have another remark that says term XYZ. And then it'll include all the lines that make up that term. Then there'll be another remark that says term ABC, followed by all the lines that make up that, which makes it real easy to go back and look at the finalized output, compare that back to the original policy, and if you ever want to validate it or make sure it makes sense, because maybe you're updating the library, making some changes to the Cisco generator, you want to make sure it makes sense. And the object group, well, we talked about that. So when you're writing a Cisco policy, using our little high-level language for security policies, how would you define a Cisco target? Well, basically, in your header section, you'd say header, some comment. Comments can be, you can just have one comment, colon, and whatever is in quotes. You can go 4 or 5 lines if you want, or you can put 4 or 5 comments, each that are all one line if you want to keep the formatting look real pretty. Follow that by target, colon, and your target platform. Cisco in this case, followed by a filter name, followed by the type of output you want, extended, standard, or object group. Now, obviously, if you're doing a standard ACL, you can't use a text name, you're going to use a number. So you'd say target Cisco, some number, it's standard. And that'll generate access list 50, foo. Juniper?
So this is the...
Peter gets to talk about his nightmare now.
Yeah. So these are all the options that are actually supported for Juniper. This is why I said that, and these, by the way, these options are supported strictly for Juniper. These actually aren't supported for the other renderers. This is why we had the laudable goal of trying to make all of the options be supported on all of the renderers, but then we saw this list, we kept getting requests from our networking team saying we need this new option, we need ICMP type, we need prefix lists, we need routing instances, and we said there's no way we're going to be able to include these in Cisco and IP tables, that sort of thing. So, yeah, I don't know. Just some of the destination prefix, ICMP type, a lot of these things just are, I don't know, they just accept strings, and they basically pass the strings directly on into your rendered ECL. And Juniper obviously all supports the source address, destination address, source port, destination port, things like that. Some of these actually do make sense in the other ones, as Tony had mentioned, things like quality of service, the QoS markings. I'm sure that there are ways to add QoS markings to Cisco Access Control List, and I believe IP tables supports QoS these days, so we should be able to implement that. Traffic type and ICMP type, certainly we should be adding to the Cisco and the IP tables renderers. Logging, stuff like that actually does make sense, but we haven't had a need for it just yet, so we haven't implemented it. Same thing, I'm sure at this point, you guys saw an example already, but this is just what it looks like to define a Juniper filter, just comment, whatever, target Juniper filter name, and then the filter option. And INET is a IPv4 filter, INET 6 is a IPv6 filter, and then bridge. And bridge is the layer 3 at layer 2. And this is Tony's nightmare.
Yeah, it is. So a while back we had, actually one of the things that got this ACL generation system going was the complexity of it. And another one was we had a problem in Google where we had what we called auth firewalls. So everywhere we had an LDAP server, Kerberos server, Radius server, other types of sensitive boxes, we didn't trust them just to be on the network. We wanted to actually have a firewall in front of them. So we bought lots and lots of these little firewalls and stuck them in front of every one of these boxes to make sure they were adequately protected. And now everybody that worked in our sysadmin team and our network team knows that that firewall really isn't doing a whole lot that a host-based firewall couldn't do itself. It's just a matter of good system administration to make sure they don't turn on ports they don't need. At the end of the day, if you're going to open something to port 80, if that's the only port running on the box, most of the time you're fine just leaving that box completely exposed to the network because nothing else is listening. It's not really exposed. And anything that's exposed on port 80 is going to be exposed even if you open it through the firewall anyway.
Modulo Cisco's IPv6 ICMP processing errors.
Well, okay. There are some problems in the stack that occasionally can cause problems, but those are few and far between. So anyway, one of the things we wanted to do to save costs, make things easier for our sysadmin teams when they're deploying small boxes, we didn't want them to have to jump through the hoop to deploy an LDAP box, then they got to talk to the security team, and they've got to build a firewall, and they got to order the hardware and configure it, and then ship it over, and it took forever just to turn up small boxes. So we came up with this idea. Our sysadmin team already had this thing called Slack that is used to throw a piece of hardware out, you run Slack on it, and each machine has a role defined and different types of applications and services that are installed, and it automatically configures these boxes, bam, like that, like magic. It makes things really easy for our sysadmins. So we wanted to integrate security into that system which is where we started writing the IP tables generator for originally. So we use it in Google as part of our host-based security system. The current format that our IP tables generator outputs into, ideally, I would like it to be something that you could just save it as a text file, type IP or cat it to an IP restore command, and it would reload. But it didn't meet the needs we had at Google at the time. So right now what it is it's basically a long list of IP tables commands, and if you pass each one to sbin IP tables, it'll implement that policy in order. Moving it to an IP tables restore version is something I'm working on now. I spent a lot of time this week working on it, but it's not quite ready for release yet, probably next week. But the version right now outputs a good IP tables policy that you can load. Internally, we've got our own loader called the project internally at Google is called Speedway, which is our IP tables replacement for all these firewalls. We support both IPv4 and IPv6 on the IP tables generation. One of the reasons for that is internally and externally, Google's been a strong supporter and adopter of IPv6, even though we do nothing on it for the most part with Cisco at this time, security-wise. The terms are rendered. When we create a term that says, anybody on the internet can go to our web server on port 80, the way that's rendered is basically we take an input table and we say, jump to this term, allow web services. And that'll say who is allowed to come in, and it'll define the actual term itself to create the policy. And then it'll either match or it'll return back to the input policy. And then it'll process the output policy accordingly as well when packets leave the machine. So currently it supports the input, the output, and the forwarding tables. Obviously, we could add support for raw, mangle, NAT. We don't right now because we don't use it internally. That's something I'd like to do in my spare time shortly. And we also support, as I'll show here, setting the default policy. So looking, again, going back to how do you write a policy for IP tables, you create your header section. You say, my target is IP tables. What filter? Well, on IP tables, you don't have filter names like, edge filter. You have input, output, and forward. And then you define a default action, which is optional, accept or drop. If for some reason, whatever the default filter is today, you want to just leave it alone, don't define a default action, and it won't change the default action that already exists. And then alternately, you specify iNet or iNet6 for the output format you want. If you don't, it'll just default to iNet, because everybody uses IPv4. That's default, right? I don't know. So an interesting note, internally, we don't write a policy that describes an LDAP server, and we don't write a policy that describes a web server for IP tables. We took a different approach on the internal Speedway project where we actually generate modules. We create one module called like 80-web services that says, on a host, I will allow inbound 80 and 443, and the appropriate replies. We'll define another module that says, I allow MySQL, which will allow port 3306 TCP in. And we may allow another one that says, allow outbound all default. And by creating a bunch of small modules, along with a base policy that says every host gets this base policy, they can create a role in our automated distribution system that links together several modules. So a sysadmin can go, I need security on this box, but it's not something that's required, but as a good sysadmin, I want to do the right thing. I'm just going to go ahead and install this Speedway policy for IP tables, and I'll include this module and this module because I need MySQL and web services. Now, any sysadmin can easily deploy IP tables without knowing anything about it at all, and we give them the tools to do the right thing because they want to without any of the headaches and hurdles of going through it, of calling up security and asking them to build them a custom policy just for this. It makes things really easy to implement security within Google.
And Tony doesn't like people calling him on the phone.
That's true, I don't. Or paging me, for the love of God. Anyway.
So
Peter wrote the glue that binds all this together.
So finally, we have the ACLGen process. So what this does is this is very basic. It essentially, calls naming, it calls calls naming to load up the definitions, calls the policy parser on each of your policy files. It returns the policy object, generates the policy object, and then passes that policy object off to the various required renderers. There are a number of arguments here. The ACLGen that we've supplied in the distribution, you can actually call it with no arguments, and all the defaults should work just fine, and you'll generate a few sample policies with a few sample filters with the sample policy that we've supplied. One of the nice things that we actually have in this version that we don't have in the version we run internally is that, so with the policy directory, I mean, assuming that somebody would run this, if somebody were running this in a company, they would most likely have the sort of thing with the policy files that are all checked under source control, source code management system. So you can easily see having a directory structure defining these things. So you have your base policy, you have like /mail, and then all the policies under there defining your mail servers, and then /web, and all the policies under there defining your web servers. When you define an output directory, ACLGen will actually read everything under your policy directory, remember the directory structure, and then output to your output directory in the same sort of directory structure. I don't know, it would have been nice if we had that when we first wrote ACLGen internally, but Tony didn't have that idea then. It wasn't until we wrote this one that he had that idea, and we went and implemented it. Yeah, that's about it. So what we described so far in the first, I guess, 27 slides is the process that we use internally at Google to generate just about all of our access control lists. So it's a way of turning all these disparate policy files into firewall filters that we can then give off to the various networking groups for actually pushing and deploying these things on the routers and systems that they control. The way that we've defined this modularly actually gives us a lot of tools for actually doing a lot of quality assurance. So that we want to actually verify that, that when we push out an ACL change that we're not actually going to take out a remote office or something if we have remote offices connecting in over VPN tunnels, or that we don't accidentally, turn down all of our front ends on the East Coast.
How many people have done that?
How many people have turned down all the
Major
front ends?
network outage because you accidentally did something wrong with an ACL. Not nearly enough of you raised your
there's
hands.
about
You're all
7 or 8
liars.
honest people out there.
Everybody does it. Okay.
So this is just a brief overview. We actually, and unfortunately, a number of these tools we actually aren't releasing. A lot of them you can sort of infer how they work, and we actually talk about how they work, but for the actual source code of them, we actually aren't releasing them. Some of them actually still have internal dependencies on particular machines and systems that we have at work, so it wouldn't actually make a lot of sense to release them. So this is just a brief overview of some of the tools that we have. We have regular reports that are generated out weekly that either report to internal websites or that generate email to alert us to potential problems. The tools we have on the right-hand side, there's the ACLCheck library, which Tony wrote. I'm not 100% familiar with it. NetFlow validation, aka Snackle. Load balancer validation. So the NetFlow validation actually, validates the ACLs based on traffic that we've seen over the last couple of weeks. Load balancer validation validates that all of our public VIPs are actually going to be allowed to receive traffic based on what we have configured in the load balancer configuration and what we actually have defined in the firewall policy to make sure those two things match up. So if we have a SMTP VIP that actually isn't allowed to speak SMTP, then we have a problem. Policy reader library, again, another one of Tony's things I'm not 100% sure about. Term occlusion, a nice way of, this is all, all these firewall filters that we write so far, they're all, as a packet comes, they're processed serially. So as a packet, it's, first match wins. So you can obviously have a case where you have a very broad term up top and then a very specific term down below, and that specific term is never going to match any packets because the broad term matches it. So the term occlusion library is invaluable in finding out cases where that happens. Especially in the case where you have very, very long firewall filters, which we have several. That tool is invaluable. And then the IP tables assurance, which is actually a really beautiful website that Tony's got, which does all the validation stuff for IP tables for Speedway policies.
So one of the things that was really painful to do is if you have a 4,000 line Juniper JCL or Cisco ACL, and someone comes to you and says, hey, will this allow X to get to Y on this port? You kind of got to walk through the whole ACL to figure it out, and that is really painful and difficult. And anyone that works in security often gets requests from some group that says, hey, we brought up the server, but it can't talk to here. How come? Well, could be a dozen reasons why. Maybe it's this filter, maybe it's some other filter further along, maybe it's this other firewall over here, or maybe it's that some term's occluding another term. So one of the things that we thought would be beneficial to have is a way of looking through an ACL and finding out what's going to happen. Doing that kind of search through a Cisco ACL itself is kind of painful. Doing it through a Juniper ACL is kind of painful. Doing it through IP tables is kind of painful. But one of the really cool things is once you have a single high-level security definition that renders multiple output, it's easy to parse through that high-level definition and make these decisions because you've done it in a very programmatic way. So what ACLcheck does is allows us to verify packets against a policy to determine what kind of matches will occur for different types of actions. So you pass it in a policy name. You pass it in the source port, destination port, protocol, the different flavors and features you need, and you say what's going to happen. And it's basically, it returns an object with a couple different methods, which we kind of walk through here. Like I can say action match and some action, accept, deny, reject with a TCP reset, or next. You know, whatever the action is that you defined in a policy. And what will happen is it'll just return the terms that this particular packet would match in given policy. You can say matches. Once you've passed it in, you get the object back and you say blah, 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 dot matches. And it'll come back and say, hey, I found 3 different terms that will match. This one it will match, and it will set the QoS, and then go to the next term. And the next one says, oh, it'll match here, but then I'm going to deny it. Or you could say exact matches, which basically excludes the next, because sometimes you don't really care if it does a next. You want to know, when does it hit the end of the line in my ACL? What is the last thing that's going to happen before I kill or accept this packet? And that's where it comes in real handy. So now that you've got this easy way to do that, you can actually throw a lot of data at it and do all kinds of really, really cool stuff, which is kind of the basis for a lot of the ACL validation tools we're going to talk about next. Because it's not enough just to write your company's ACL policies. You want to make sure they work, and they work right, and you don't have a huge outage. Because, damn, I hate that when that happens. So Peter, a.k.a. Snackle Moody, will talk about his creation.
Tony's been dying to say that. So as I mentioned before, one of the things we do, we maintain NetFlow data. This tool, what this tool does is this takes a proposed ACL change and takes NetFlow data of traffic that would have flown through this particular ACL and compares the actions that, so what happens to each one of these packets as it flows through this current version of the ACL and compares that to what happened when it flowed through the same ACL 2 weeks ago. So the good thing to look at here is the differences between the two. So if 2 weeks ago you had a packet that went to a particular VIP on destination port 80 and it used to be accepted, and now this week that's getting denied, we see a report. So that delta right there generates a report. Vice versa, if we have something that used to be denied and is now accepted, that will also get generated into a report for us. So this is really great because if we have several million lines of NetFlow individual sample packets, you can turn that into several million lines of potential, like accept, deny, reject. You can turn those several million lines of packets into maybe 10 or 15 actual lines that you have to pay attention to. So it's a great way of actually summarizing information. It allows us to easily detect errors before they might affect our end user. So, for example, as I mentioned before, if we accidentally turn down HTTP to the East Coast VIPs, things like this, that would show up very, very loud. And obviously, this particular tool is great for detecting problems for services that you accidentally turn down, because this relies on traffic
on traffic that it's seen. So it's sampled traffic. So if you have a service that is already, you have a service that's already accepting traffic, where chances are we're going to see net flow data for it. But if you accidentally turn up a service, if you accidentally turn up a cluster, if you accidentally turn up a port on a cluster that shouldn't actually be accepting traffic, you're not necessarily going to see this, because the traffic that was denied before and is now accepted, there's not going to be any traffic to run through that. So I believe on this next slide we actually have an example Snackle report. So this is the sort of thing that we see. Each one of these lines represent individual packets for which the action was different in the previous run than it is for this run. So in this first line, the ID is just whatever ID of, it's just from the number of packets that we had. So source IP 6481.4774 on that source port used to not be able to go to that particular VIP 2 weeks ago. And it used to be discarded by this term, global discard reserved. And this week it's actually accepted in the global accept transit customer. And then vice versa for the accept to deny. So we've got that particular IP address on that particular source port used to be accepted by the global accept transit customer, and now it's being denied. I think these are actually the same IPs on both sides, which is unlikely to ever happen, just like this. But this is just an example, just to show you that you might have several million lines, and like I said, this would turn into you'd have maybe 30 lines of output here, and this, by giving you the ports that are the IPs and ports as well as the term numbers, you can then hopefully if your policies are off in your source control management, you can actually go back and check and see, okay, I see that Peter made a change, and is this actually denying what I expected to deny, or did he fat finger something? Did he accidentally add port 80 when he shouldn't have added port 80? Now Crackle. We're good on...
That's the best you can do? All right. Thank you, Snackle.
Snackle, Crackle, and Popple.
Anyway, so VIP validation is very important at Google. As I mentioned, I think in the second slide, we've got like 6,000 public IPs that provide services. Most of them provide multiple services. So accidentally blocking HTTP to, say, all the Gmail VIPs might be perceived as a bad thing to bloggers and the press. We've never done that, ever. The outages have always been the other guy's fault. Really, I'm serious. Anyway, so we do not ever want to see ourselves going to Eric, Larry, and Sergey and saying, yeah, sorry about that. Gmail was out for 4 hours because we wrote an ACL and we didn't look at it close enough and it killed some service like Gmail. That's not the position anyone wants to be in, especially when sometimes a bad ACL push can result in customers' private data getting exposed. In most cases, that's not. We've got other layers of control behind that, but we don't want to be in that situation.
In all cases, we have other layers of controls behind that.
But okay, in all layers, yes. But we certainly, if we block AdSense VIPs, how many millions of dollars will be lost a minute or an hour because we've made a typo? You can't afford that kind of outage in a large-scale operation like this. So what Crackle does is basically, it goes in and we've got all these configurations for all of our load balancers that control all of the VIPs on the front-end services and ports and protocols and how they map to our back-ends. And what we want to do is compare those configurations of our public VIPs to determine what should be available. And now when I've wrote a new Edge ACL that I'm getting ready to push out globally to all of Google, obviously we're going to canary it and stuff first, but at some point there could be an outage. Now what I want to do is say, hey, is this new ACL I've written going to block any of these things that are expected to be run because the SRE teams have turned up these VIPs and ports? And it'll generate a report that comes out and says, hey, by the way, did you know they're running IMAP with SSL on this VIP, but you're not allowing it? You might want to go ahead and check before you actually push this ACL. That's kind of handy stuff to know. One of the other benefits we got out of it that we didn't think about when I wrote it was it identifies stale and misconfigured load balancers. So sometimes you get a load balancer and someone deploys it in a production rack and leaves some default configuration information on it that shouldn't be there. And it comes back and says, hey, this is blocked, and we look at it and we go, no kidding, it should be. And then we can call that team and say, you need to update your procedures. Somehow someone installed something that shouldn't be there. Again, very handy to have. And it has saved us from inadvertent outages on several occasions already, so it's more than proven its worth. I know, the font's really small, and I apologize, it's kind of hard to read, but I wanted to give you an idea of what some of our internal tools look like. So unfortunately, like Snackle and Crackle, we're not releasing to the public right now because they've got too many other Google dependencies, but we're going to try to find a way, if there's a way. The problem is everybody runs different kinds of load balancers, so there's no way to write a general load balancer parser and stuff. But if we can ever do that, I'd like to release this. So internal, we've also got a page we call Looking Glass that kind of gives us a view into some of our ACL-related stuff. And a friend of mine at Google, Ogden Trumick, is the one that started work on this. So in this case, I generate a text report for Crackle that gets sent out to our team. But we also go ahead and import it into this NAC view so it's real easy to look at. In this example, you'll see, like on the very first line, you'll see, hey, Sunday, October 4th, 2009, I checked TCP port 80 on 4,592 virtual IPs, and my result is it's okay. We look good on HTTP. And then I walk through all the different services that I've iterated off all these different NetScaler configs, and eventually down here we see I checked TCP 25 on 130 VIPs, and I found a warning. We're potentially doing something bad. And it says public address to this VIP on port 25 TCP will result in a deny. And it's got a little more button. You click more and it expands it. Now again, because we've generated our ACLs programmatically with this language of ours, I can say 25 TCP is contained in the following service tokens: SMTP, Gmail POP, Google Public, and Control. So now I know that whatever should be allowing that will have one of these services. And I know that this IP right now is contained in the following service or network tokens: Google Public Networks, prod external dub. So I know that it has something to do with probably one of these tokens if I did want to allow this. So now I can go through our edge policies and say, here's some related terms that are probably related to the problem you're having here. And we list, I think it's 4 or 5 terms. One of these is the reason you should be allowing or shouldn't be allowing this term. And that makes it real easy now to debug. And this is a problem we never would have noticed in the past, but is real easy to detect now. For IP tables, we have something similar. When Speedway was originally written, it was kind of a shortcut. We made this great way to deploy it and to get it running and to get it out there and get it working. But one time, my manager came to me and said, by the way, I know Speedway is getting really hot and I'm hearing all these good things about it. How many machines have we deployed Speedway on? And I kind of just had to look, I have no idea. I said, it's all deployed through this other system that our sysadmin team controls. I don't know how many deployments there are. So since the project was called Speedway, I decided over Christmas break I wanted to find a way to figure out where they're all at. And Speedway kind of has to do with racetracks, and I want to poll all these machines to find out where they're at. So I thought, pole position. Okay, that's what we'll call it. Anyway, so what we did is I added a little bit of feature to it so that all these deployments, once it's installed, we already had some assurances where it would immediately hash the IP tables rules that were installed. And it would store that in a secure location. And occasionally it would poll it and determine what the current hash is so we would know if anything ever changes. And when there was a problem, well, we'll go on to that. And we also know the role and the modules, and all this data was stored for our kind of central monitoring systems within Google, but there was no real way to keep track of it. Each team monitored their own Speedway deployments. So I added one little additional piece in, which was basically a little TCP application that would store all this data, and as soon as I performed the hashing operations, aka like tripwire light, if you will, it would send that securely back to a central collector, which we call pole position. And it would report at regular intervals, and the server would monitor, and as soon as you checked in the first time, that server would say, ha, I've got a new Speedway deployment. I'm going to start tracking him, and if for any reason he doesn't report for so many cycles, I'm going to raise an alert and say, there's a problem with this machine. He stopped reporting, but he used to be there. And then the other team can go in and clear that if they want, or find out what's going on. And it also will tell me, well, okay, let me get a little more detail. So When you send this data to the pole position collector, it's going to validate the report and make sure it's a valid Speedway report. It's going to store it in the database. It's going to analyze it for issues and show all this detail through the web user interface. And here's an example of something what that looks like. I wanted it to be useful for our security team to be able to go and look and count how many deployments we have of IP tables out there. But I also wanted it to be useful for our sysadmin teams so that they could look at their individual deployments. So for example, you'll see this role view on the side. So the sysadmin team that runs our LDAP groups can click on this and it'll show them just the LDAP hosts running our Speedway deployments. And it will be able to tell them which ones are running correctly as expected and which ones are having problems. So you'll see there's 3 drop downs. The first one is like news and announcements. It's always closed. The second one is LDAP alerts, which I've closed in this point so you don't have to look at it. But it would contain just the machines that are having problems. The third one is a list of all the machines that are having problems or operating correctly. You'll notice the very first one, called VC LDAP, is running the role auth.ldap. It's at this IP address. It was updated on this date, and there's a warning that says hash mismatch. And as you mouse over that, it'll come up and say, hey, the MD5 hash of this policy doesn't match what was installed and what's currently running. Other things can be, hey, I can't find hashes at all. Speedway isn't running at all. Something's wrong. Or the alert could be, I haven't heard from this guy in 6 hours. Something's wrong. You might want to figure out what's going on. Policy reader. Not a big deal, but one of the problems with the policy library is it takes in addresses and service tokens and kind of mashes them down into something the generator can use, but it's not very people-friendly. And if you want to programmatically do something with policies, like find out how many tokens or how many policies use the token internal networks, it's kind of hard. You could grep through all the files, but maybe you want to ask something more complex, like how many of them have internal networks and is using a protocol TCP, but only is related to these 8 ports or these service tokens. And you want to be able to do it in a kind of a programmatic way. We came up with this policy reader library to do just that. That basically reads in the policy but keeps it in a human level format so you can do real simple actions in Python to inspect a policy.
This is being released as well.
This is included as well, as well as the ACL trace is also included in what we're releasing. Another cool thing you could do with this as well is because it takes that policy, original policy, and makes it real easy to handle in Python, if you wanted to output it to a nice web user interface and maybe create something where you can edit, update, view policies in a web user interface or some other GUI, it'd be real easy to do.
So the term occlusion library I had mentioned before, like I said, all of these firewall filters that we deal with, they process packets serially. So, it's the first term that matches a given packet is the action that's taken. If you have policies that have lots and lots of terms, I mean, we have some policies internally that have, I don't know, easily in one filter we could have 70
billion
80
terms.
We could have 70 or 80 terms easily in one filter, and in a given file we might have 200 filters at least, or 200 terms at least. So it's because these are all first match wins. As Tony had mentioned before, if somebody comes up and says, I would like my IP address is this, and I would like to get to this IP address on this port. Does this work? And you go look at the policy, and you see yes, this IP address can get to this port. This is accept your quality of service is this, you can get there. And they come back and say, no, actually I can't. And you're like, well, I can see the exact term there. What's often happening is that that particular term, all of the packets that would match that term are being occluded by some term that's up above it. With these super long policies, this happens, way more frequently than we'd like. And being able to keep all this stuff in your head is a real pain in the ass. So, we have this term occlusion library which does this for us, which will, look and look at all of the different terms and say, are there any portions of any of these lower terms which are being occluded, either through quality of service or, ports and protocols? So, will there be a case where a packet might be misquossed? You might have lower quality of service applied to packets up above. Maybe you actually want super high quality of service applied to your video traffic or something.
is misquast a word?
Quast?
Misquast?
Misquast? I don't know. I used it.
I think she used to live down the street.
Oh, really?
Okay.
I didn't know her.
I'm just trying to throw them off. Go ahead.
So anyway, yeah, so I wrote the term occlusion library. I accidentally misused the term occlusion library once, and we misquast a bunch of traffic. But yeah, so otherwise, other than my one misuse of this, this library is actually really, really useful. Unfortunately, though, this is not being released at this time.
We'll get it out there shortly. Maybe.
So in summary, as the back of the shirt says, do no evil. Access control lists are highly prone to human error. One of my favorite, I was writing an internal talk like this, and I went back to go look at some of the original changes I had made when I first started at Google, and I probably had, I don't know, at least a quarter of my changes that I would check in. I would look at the description, and it was like, oh, I missed a curly bracket here. Oh, I missed a semicolon. And these, these are just really...
Transpose 2 digits.
Yeah, these are really, really dumb errors that you shouldn't actually be making. So they're highly prone to human error. Auditing and reviewing these ACLs is, almost the worst thing ever. On a scale of speaking at Lisa to auditing these ACLs, it's on the complete other end.
Yeah, it's really, really cool when you've got 200 ACLs that get updated in a change, and you can do the review on it in 1 minute. Because the only thing that really changed was the network definition for public net blocks, added a new subnet, and then you typed make, or ACLgen in this case, and it generated 200 new ACLs that are going to get pushed out. And you know that because you trust this library because it's worked over and over, all those changes are perfect. That makes life so much easier. Imagine having to go in and update 200 files individually and never make a typo, never transpose 2 digits, never mismatch a net mask.
Emacs will actually do that for you.
I'm a VI guy, sorry.
Emacs.
Wouldn't that have been easier? Wouldn't that have been easier? Why didn't you say this a long time ago?
Yeah, I didn't want to, Lisp is the problem. Anyway, so as Tony said, so keeping large blocks of networks in sync between large number of ACLs is time consuming and error prone. And again, automating these tasks. This is a huge time sink if you're not automating these tasks.
And you can train new guys. We have new guys that come into our NetOps team that used to take 6 months to learn all our ACLs and how things are done 5 years ago, who you can come in, and when they get a remedy ticket that comes in and says, here's a new public VIP, they don't need to know anything about our ACL system or what ACLs go where or how they go. All they know is, oh, I just update this definition file and rerun make. And bam, all our ACLs are updated. Training, actual intelligence required to do things, much lower. You just got a smarter guy doing the reviews. Sorry, Peter.
That's why we can continue to work there. We've lowered the bar for us to be able to stay working there. And so finally, we've talked about it being open source. This is the location of the code.google.com /p/Capirca, Capirca, as I like to call it. As Tony wrote here, the name Capirca was intended to be Capirca from BSG. I'm sure you guys all watched it, and I'm sure
Galactica fans, woo! Yeah.
I'm sure you've seen the plan, right?
I misspelled it. I suck. Okay.
Yeah. So he
And then I
misspelled
left
it. It turned out to be a fortuitous misspelling because it turned out that there actually already was a project called Capirca. And despite the fact that we work at Google, we don't wield godlike powers for all Google properties. So Capirca remained where it was, and we kept Capirca. And also,
Yes, I
we wanted to
thought
keep the
about
lawyers
going to
away.
the guys that own code.google.com and saying, hey, find this guy's project that owns Capirca and just kind of lose his project, and I'll re-register. But damn, don't be evil thing. Ugh.
Yeah.
Anyway.
So that's about it.
So that's why it's misspelled. It's Capirca
It's
now.
actually not misspelled. It's correctly spelled. If you control the past, you control the present. So now I guess if you guys have any questions, we will do our best to answer them.
One of the things that I thought was pretty cool that you did was the NetFlow-based tool.
Mm-hmm.
And it occurred to me this is more of a comment, just to compliment you on that, but also I like the idea of synthesizing your own flow records and then using that as a test suite. Because you were talking about you were replaying past stuff, but those of us that want to use this kind of tool, we could also just make your own synthetically, and I have a Perl module that lets you do that, but you could just have a different flow file for different, canonical behaviors and just run it through and it'd say whether passed or failed. So I think that's a really neat way to also to overcome some of the things that you're not releasing yet. We'll have tools that
So we actually do have that. I didn't actually mention it, but in that in Snackle, there are actually two modes of operation, and one is to use net flow data, where you point it off to a location where you can find the net flow data, and the other is you say, I want to generate 1 million packets from, source address from this range, destination address from this range, source port from this range, et cetera, et cetera. And that will just, generate you 1 million packets in those ranges. That turns out to be really useful. For some of the, as I said, the net flow data is sampled, so some of the less used paths that we have, if I want to get 1 million packets from an unused, a network path that isn't used very often, there's no way I'm going to get 1 million packets, even highly sampled packets. So we use that other mode, exactly what you were talking about, but that ends up being a lot more noisy because that will catch basically every change that you had made. That'll show up in there. Not just because it's not just looking at traffic actual traffic that you've seen. So it is very useful. And
and you could
you've
also
got a great idea.
The term occlusion thing, you could do that with it too.
Right.
Hi. You mentioned that all the firewalls that you were generating for were based on first match models. I'm just wondering how difficult it would be to allow for last match models like OpenBSD's PF. Also excellent project, thank you.
How difficult would it be I don't think it would be.
For a last match policy, it wouldn't be any different. If you wanted to write a generator for some other platform that did a last match,
the difference would just be in
piece of cake.
In the quality assurance stuff. So in the Snackle or whatever, it wouldn't. Those sorts of libraries, those sorts of tools would have to be updated so that it would know that it wasn't a first match win, that it was a last match win.
Now, actually, the only caveat to that would be like the ACLcheck library we're releasing as well, which if you have NetFlow data, makes it real easy to write your own tool to do that. Let me think, if you're doing the exact match method, it's not going to work for a last match type situation. But if you use the matches method, it's going to show you all the matches, regardless of whether that's a definitive match or not. Like if the first match is accept, it's also going to tell you, and if I kept going, here's where else it's going to match. So then what you could do is just look at the last one returned in that list. There's your answer.
Yeah, so again, the rendering would be totally fine. It would just be the quality of the QA tools would have to know if it's first match or last match.
See, hooray for many methods. Okay. Yes,
In the
I'll
front.
go up front.
Okay. First I have to apologize to the room. My last job, I implemented a tool much like this, so I have a list of about a dozen questions I want to ask. But I'll ask the first one and then yield to someone
Wait, if you've
else.
done it, give us also suggestions.
Exactly. So I'm going to ask my first question and then yield to someone else. The first question was, are you also managing the ACL application? Which is to say, this particular VLAN on this router has this ACL applied, or are you still doing that by hand?
The network devices are actually controlled by the various networking teams. So we would say to them, you have an Eng VLAN, you have a contractor VLAN, you have some special lab VLAN. This is the access control list that gets applied to that VLAN, and then they're the ones that actually go off and push that.
Yeah, so the way that we would do that was in the same tool, we would list entries for the VLAN so that the tool, when it applies the ACL, actually touches the VLAN itself, so it knows, I found this subnet on this router.
We used to do similar things like that, like in the comment section at the beginning of an ACL, it would say, this is applied to this router on this interface, in this direction, and blah, 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 blah. And unfortunately, it gets a little unwieldy when you've got 17 billion routers and interfaces. What we ended up doing is we have a tag system where we define this type of network has these type of boundaries, and any router that's installed that's touching one of these boundaries, this interface has to be tagged. And that tag will specify this is a external edge. And every interface that's an external edge, we know must have this ACL applied. And if this is an internal edge to a corporate network, it must have this type of ACL applied. So then we have other tools that actually take all those ACLs we generate, push them out to all the routers, look at all the interfaces and tags, and apply them wherever is appropriate. So now we kind of depend on the network engineers to make sure the interfaces are tagged correctly. And then we also have audit tools that occasionally go out and look at that.
Yeah, but I mean, the way that the responsibilities are separated at Google allows us to not actually have to worry about that. If we were the ones that were actually pushing these ACLs, I'm sure we would end up having to come up with something similar to that. But we get to just write the ACLs and say, screw it, we're done.
I will also say there's other tools I've written in relation to this that we haven't talked about that basically read our Juniper. There was a slide that basically touched on it, if I go back, and I didn't really go into a lot of details. On this here, when I first mentioned the ACL check library, under it I've got this two things, NAC parser and ACL trace. NAC parser library, which I didn't discuss even though I kind of intended to, actually reads every Cisco, Juniper, switch, router that we've got in the company, all have their configurations pulled into a central location at regular intervals. And this actually goes through and reads all those router and switch configs of the different formats and builds tables, large tables that says, here is an IP address, and it matches this interface on this router. And this router is of this type with this version and so on and so on. And likewise, you can say this router, and it'll say, oh, has these interfaces with these IPs and these secondary IPs and these net masks, which is what we use for the ACL trace library, which I didn't really, again, talk about, so that we can do like a trace route. And you can say, from this machine to this machine, let's do a trace route through the network. But instead of just saying the hops, I can say the first hop it hit is this IP. And this IP, I do a quick lookup to what device it's contained on and what interface, and it says, it has this input filter. And I can return that, run the ACL check library, and say, and it would match this term based on that packet. And then I can say, now, the next hop, all I know is the input interface of the next hop, but I can look at that router that I had the input on the previous hop and guesstimate the output interface. And then I can do a quick lookup with the ACL check and the ACL trace and come back and say, and this output filter would be hit, and you'd hit this term, and on and on. You can step your way through the whole network logically. So we do read router configs. We don't do it in a way to apply the interfaces, but we can do it to look at all the different interfaces and see what's applied where based on just an IP, for example.
So quick follow-up on that. Since you have this tool and you're pulling in the router configs and you're looking at the way things interconnect, are you dealing with redundant route paths, and have you or anyone else thought about building a tool to audit to make sure all of the route paths between these two endpoints result in the same behavior, so you don't have connection fails, enough behavior changes because
that is absolutely the correct idea and the right way to go? No. We do it from the simple approach of take the trace route data and immediately pass it to this other library that does all these cool things. One of the things we do, though, since we push all of those routers into one repository, is if we think there's a problem, for example, with our filter between our production network and our corporate network, we can say, every version of this filter that's applied to a router, what's the P4 revision? And oh, look, they're all number 287, except these three routers are 253. Why haven't they been updated in the past 20 revisions? That occasionally, we don't do it systematically, but we do it when we detect problems occasionally. So yeah, we experience the same problems, and we should probably automate that as well. That's a good suggestion.
In the tool I use to handle IP tables generation and distribution, I have something similar to pole position, except rather than returning a hash, it actually returns a diff between what it should be and what it actually is. Are you thinking about extending pole position out so that when I see the problem, I actually have some information to actually try to troubleshoot what's happening? And for instance, we've detected cases where somebody left a port open, there were entries to people's houses that shouldn't have been there, and things along that line.
That's
a good idea.
A good idea. It was one of the things that was discussed earlier on of actually sending basically a diff between the two so we know exactly what happened. Was it a local sysadmin that just did an IP tables flush to get rid of the rules because he thought it might be interfering? Or did he add a backdoor to let something in? What we ended up doing was we send the current, just the hash. But one of the things we kind of get that from that a little bit is we also store all the historic hashes. So I know the current LDAP role should all have this hash because they're all running identical IP tables rules. And if I get a hash that's different, I can go, let's look through the previous IP or
And see if it matches
LDAP
a prior
roles.
revision.
Does it match any of those? And I can just tell him, you're running 2 versions old on your LDAP policy. And if it's anything other than that, I can go, woo, crazy policy.
Right. Yeah, we actually embed SVN IDs in the rules files we push, so it's easy enough from the diff to tell if something's changed because it has a different SVN ID.
Yeah.
Yeah, that's good.
Thank you.
Oh, why? Are we really out of time? It's the last talk of the day. Come on. Okay. Go ahead.
I actually have a question and a quick comment. You guys have an edit on your ACL library slide. It says library. And I did tweet it because I do send text edits to Google people live, so I'm sorry.
What slide is that?
ACL library.
That's the
Exhibit
slide
6.
he wrote, I think.
I gotcha.
ACL library?
The second one. That's
This-
just titled ACL library.
Oh,
ACL check. Sorry, ACL check library.
Oh, that's your library, buddy.
No, come on now.
Anyway,
Thank you.
You know what?
library.
Normally I would flame you on a mailing list, but
Dude,
because we
I was
have one
actually live
Google
tweeting
security
during
do
your
no evil
talk.
shirt left.
I also slammed you for not giving me one, so thanks.
Whoa.
I actually had a comment that might be more interesting, or a question. Last night, Brent Chapman was talking in his Guru session about what he thought would happen with IPv6 migration. And he said, based on a kind of seamless, transparent experience he had in a Mac environment, he was not worried about it at all. What do you guys think? Are you worried?
Worried about IPv6?
Yeah, about
There-
the migration.
I'm a security guy. I'm always worried.
Oh, me too. I'm sure all of us are
He's
worried.
also a
but what
father
do you
of a
think will happen?
19-year-old girl, so he's
I'm
always
always
worried.
worried.
What do you think will happen, though?
Wait,
So
happen security-wise or happen adoption-wise?
Adoption.
Okay. Yes, people will
Thank
adopt IPv6.
yeah, that's an easy question. Yes,
What
IPv6
will
will be
happen to
rolled
people
out.
like us?
We will be put out of business because IPv6 will become self-aware and I
Awesome.
mean,
Thank you.
One of the things that scares me the most about IPv6 adoption for like a corporate environment is we can finally have every single person's desktop computer have a publicly addressable IP address, which is really cool because all the applications you can enable with that. The only thing that scares me though is when you have a stateless ACL filter, for example, on a Juniper or Cisco router, and you've got to allow DNS replies.
right.
God forbid anyone runs any application that listens on a high UDP port, because there ain't crap you can do to protect those internal workstations without a fully stateful firewall. And if even one hole gets opened in your network, they can access your machine directly.
And we're done.
Oh,
Yeah.
3, 2, oh, I'm over. Damn,
Yeah.
I'm sorry. Overall, I think IPv6 can be made very secure. I think it's a better way to go. I would much rather have everyone's machine have a publicly addressable address and get rid of NAT entirely forever and never let it return. But I'll take the security risks for that.
Okay. Good job.
Mr. Snackle.
This is, I want to show you guys something. If he's going to do Mr.
No,
Snackle.
we gotta go now. You would.
I would
All right.
too.
Thank you, everyone.